In this video, we're going to discuss units in a little more detail. So we've discussed what type of units there are. We said things like mass. There were the grams. Things like length. There was the meter, or time. There was the second, amount. There was the mole. Well, basic units are used for more than just their own existence. If I have a length, that can be a meter, but if I have two lengths, what I end up with is an area. So if you have something that, say, is 2 meters by 2 meters, well, 2 meter times 2 meter is 4 meter squared. This is an area. If I have meter squared, that is an area. By combining two different length units in different directions, we can get an area. This continues. We can have, if I have a length by a length, and I have it again, meter by a meter by a meter, this is a meter cubed. This is a volume. So meters cubed are volumes. There are many, many things that we measure that are actually combined units, where we have mixed either multiple of the same or multiple different units together to create a larger expression. I can't tell you how much water there is by just using a meter. I have to tell you the volume of it. You buy water bottles in half-liter amounts. You don't buy them in quarter-meter heights. In fact, water bottles, we don't actually do cubic meters. Just for reference, a cubic meter is basically 2,200 pounds. So you really can't put that on your backpack and go hiking with it. Reasonable human scales is that we use a much smaller portion of this. So if you imagine looking at this giant meter by meter meter cube, if we were to cut it into 10 pieces and have one going away, we could make a smaller cube. In fact, we could make a bunch of smaller cubes. By cutting it into smaller and smaller pieces, I can talk about smaller and smaller volumes. So if we have a smaller cube, we can have a cube that is a decimeter by a decimeter by a decimeter. So this, remember, a deci is 1/10. This is a tenth of a meter, not quite round the scale. Well, a decimeter times a decimeter times a decimeter is a decimeter cubed. This is substantially smaller. In fact, it's 1,000th. Each time we turn one of these meters into 10 pieces, it becomes 1/10 the size. Do that 3 times, a tenth, a tenth, a tenth, it's 1,000th. So there is 1,000 decimeters cubed in every 1 meter cubed. Well, why do we care about this? Is that 1 decimeter cubed is 1 liter, written as 1 capital L. So the volume unit we tend to use is liter. We tend to talk about liters. Liters are a volume, though. They are a distance by a distance by a distance. And so 1 liter really is a decimeter cubed. You'll see this in a few countries. I believe the UK tends to label a lot of things with it. In the US, though, we use the liter, and a lot of the world uses the liter. Just to know where it comes from, so our volumes, we tend to use the 1 liter for a volume. It's simply a much smaller 0.001 meter cubed. Well, back to some other combined units. Let's think of a few. So we said we had volume, we had area. What about speed? If you think about it, miles per hour or kilometers per hour, I need a distance and a time. And so this is a combined unit. Speeds are based on how far you go and how long it took you to travel. And so that's a combined unit. we tend to have things, if you do any physics, energy. It is a mass times a distance, so kilograms and meters, times acceleration, which is meters per second squared. So this sometimes is written as kilograms meters squared over seconds squared. The idea, if you have a weight and it moves a distance and it's accelerating, so take a 5-pound weight and drop it 1 inch onto your hand. It hurts a little bit. Take that same 5-pound weight and drop it from the top of your roof. It's going to hurt a lot more when it hits. It traveled a farther distance for the same pull of gravity. Gravity is an acceleration. It's so many feet or so many meters per second squared. In our case on Earth, it's about 9.8. The weight weighs some amount, and it travels a distance. An object that falls a short distance hits softer than an object that traveled a farther distance. Drop a glass 1 inch off a counter, it's probably okay. Drop a glass a meter off the floor, it might shatter. And so energy is also a combined unit. We won't use it in this form very often, but it's an example, and energy itself does come up later. More combined units, things like rate, in how fast something happens. Generally, we might think about this as, say, $15 per hour. Rate of pay. In fact, speed is a rate. It's a distance over time. In chemistry, though, we tend to care about moles per liter per second. Basically, how many things in a volume are happening per second. If you had a bigger container, it just means each part of the container has this many happening per second. So your bigger container may have more total because it's twice or 10 times the size, but each individual liter has this much occurring. And so it tells us how fast a reaction goes. And while there are many, many combined units, we'll leave off with just one more. Density. Density is mass over volume. So this will be grams over milliliters. Now what's a milliliter? Well, a liter was a unit, and if we are a milliliter, then I must be smaller. Remember, milli means 1,000th, so 1 liter, I must have 1,000 milliliters. So a milli means you're really tiny, you have 1,000th of the big thing, so it takes 1,000 of them to add up to the big thing. This is also 1 centimeter cubed is 1 milliliter. So volumes have a lot of different values that get used in different situations. So just a few extras here. If you go into the medical field, you might talk about cc's. 1 cc is 1 cubic centimeter, 1 centimeter cubed, which is 1 milliliter. They are all exactly the same unit. They just get called different things. They're not even conversions. They are literally the same unit with different names. But a lot of times for density, grams per milliliter is important. If you have something like aluminum, well, aluminum is lightweight. That's why we use it for airplanes. That's why we use it a lot of times for bridge components. It doesn't weigh a lot, but it's still pretty tough, like steel. Aluminum has about 2.8 grams worth of aluminum for every 1 milliliter of its volume. So if you have pure aluminum block, it weighs about 2.8 grams per milliliter. If you have your iron, it's about 7.9-ish grams per milliliter. This off the top of my head. That is substantially heavier, like 2.5 times. So if you make something out of iron for the same volume, it's just going to weigh more. And there are elements that can be much heavier. Gold, tungsten, and the like are enormously dense, nearly 20 grams per milliliter in some cases. As a result, they feel incredibly heavy. If you ever see a movie where somebody picks up a gold ingot, they are not doing it right, because that bar that looks like it probably weighs like a dumbbell weighs about 10 times what you expect it to weigh. Density itself comes up for lots of materials. It's actually a very easy way to test what a material is. If you know its density, well, aluminum, pure aluminum, will always have the same density. So if you measure an unknown object, find its density, and it matches that of aluminum, you can reasonably say it's probably aluminum, because every element has its own unique density in its solid state. All right. That is our look at combined units. The idea that these individual units we've learned can be used collectively in different proportions to tell us different pieces of information.